All right, so let's finish up section 9.5 of the binomial theorem and Pascal's triangle. We've looked at how we can create those coefficients either from Pascal's triangle or from using our NCR formula. We've seen how we can build a whole row in Pascal's triangle, like x plus y to the fourth. Now let's see how we can utilize that to help us expand a binomial. So over on page 659, they talk to us about binomial expansion. Now, when they talk about expanding a binomial, what they mean is if they gave me something like 2x minus 3 to the fourth, that literally means 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. So I would have to do 2x minus 3 times 2x minus 3 and FOIL that out and get a trinomial. And then multiply that by 2x minus 3 and combine like terms. And then multiply that by 2x minus 3 and combine like terms. It can be done, but it's just a great big mess, right? That's expanding a binomial. So what we want to do is use the binomial theorem and Pascal's triangle to help us expand those binomials in a little easier way. So when we say expand a binomial, this is not what we're talking about. Not one of my students, just something off the internet. All right, that is not what we mean by expand a binomial. All right, what do we mean by expand a binomial then? Poor Peter. All right, if I have x plus 1 to the third, that literally means x plus 1 times x plus 1 times x plus 1, only I don't want to have to multiply it out to get that. So I'm first going to create the third row of Pascal's triangle, x plus y to the third. So I'm going to go through and I'm going to pull off 1, 3, 3, 1, either from the triangle or from the binomial coefficients formula, the NCR formula, right? And then I can go back and say, okay, I always start with x to the n, and n here is 3, so I'm going to say x to the third, x to the second, x to the first, no x. My x's count down. My y's count up. So I'm going to start with saying no y, y to the first, y to the second, y to the third. So that gave me x plus y to the third. Once I create that pattern, I could go through and I could evaluate an infinite number of cubics at that point. They could give me anything they want to. They could give me x plus 1 to the third. They could give me x minus 1 to the third. They could give me 2x minus 3 to the third. They could give me x squared minus 5x or minus 5y to the third. They could give me anything. Because once I've got that pattern, here's all I have to do. I'm going to go through and I'm going to put the first value in the place of the first value, and I'm going to put the second value in the place of the second value. In this specific example, we're going to put x in for x, and we're going to put 1 in for y. So we'll come over to our formula and we'll say, okay, in that first term, let's put x in for x and 1 in for y. Well, I only had an x, so let's put x in for x. In the second term, let's put x in for x and 1 in for y. X in for x and 1 in for y. In the third term, we'll put x in for x and 1 in for y. And in the fourth term, I didn't have an x, so we'll put 1 in for y. And then we'll simplify. So we have 1 times x to the third, so that's just going to be 1x to the third. We have 3 times x squared times 1, so that would just be 3x squared. We have 3 times x times 1 squared, so that's just 3 times x times 1, so that's 3x. And then we have 1 to the third, which would just be 1. So that answer, x to the third plus 3x squared plus 3x plus 1, that's the same thing I would have gotten if I had done x plus 1 times x plus 1 times x plus 1. Let's take that same pattern and let's alter it just a little bit. Instead of it being x plus 1, what if it was x minus 1? All right, what happens if we change the sign? If it's addition, all the signs are positive. If it's subtraction, the signs just flip-flop. If it's subtraction, it's going to start positive and then it's going to go negative, positive, negative. Let me prove that to you. Let's say that we had done x minus 1 to the third, okay? So we would have been putting negative 1 in the place of y, right? So here there was no negative 1 to plug in because there was no y, so that first term would be unchanged. Here I would be putting a negative 1 in instead of a positive 1, so negative 1 times 3 would have given me a negative 3. Here I would have been putting in a negative 1 in the place of y, so that would have been negative 1 squared. Negative 1 squared is positive 1, so 1 times 3, this still would have been a positive 3. And here I would have been putting in a negative 1 cubed. Negative 1 cubed would be negative 1. So you can see if you literally put negative 1 in the place of y, those signs will lay themselves out. But you can also have a foolproof way of going back and just checking them if you know, hey, I know that my signs are going to start positive and they're going to flip-flop plus minus every single time when that's subtraction. So that gives me a quick, easy way to check my signs to make sure I didn't drop a sign. All right, let's look at another one of those. For the next one, they give me x, they asked me to find 2x minus 3 to the fourth. So in order for me to do 2x minus 3 to the fourth, I first have to do x plus y to the fourth. I got to get my pattern, right? So we're going to go to the fourth row of Pascal's triangle and pull out our coefficients, 1, 4, 6, 4, 1, okay? So we could go through then and say 1, 4, 6, 4, 1. Our x's are going to start with x to the n, and they're going to count down. So n is 4, so we're going to start with x to the fourth, and then x to the third, x to the second, x to the first, no x. Our y's are going to count up, so we're going to start with no y, y to the first, y to the second, y to the third, y to the fourth. Now, I know that is sitting right up here, and we could just copy it right down here. But when it comes to our quiz and our test this week, I'm not going to have a book or a note sheet to copy that off of. And so that's why we keep practicing how we can generate that row for ourselves. Okay? So once I've generated that pattern for x plus y to the fourth, now I could go back and I could find anything that they asked me to the fourth. In this case, they asked me 2x minus 3 to the fourth. That means I'm going to go back and I'm going to put 2x in the place of every x, and I'm going to put negative 3 in the place of every y. So let's do that. Let's put 2x in the place of every x for starters. All right, so I'm going to come over here. I've still got those coefficients, 1, 4, 6, 4, 1 that we got from the fourth row of Pascal's triangle. So let's go through and let's put 2x in for x. So this first one was x to the fourth, so that's going to be 2x to the fourth. Then I had x to the third, so that's 2x to the third. Then I had x to the second, so 2x to the second. Then I had x to the first, so 2x to the first. And then I didn't have an x at all, so I don't need to put a 2x into my last term. Then we're going to go back and put negative 3 in the place of y. I mean, literally, it's like erasing the y in your formula and replacing it with a negative 3. So I didn't have any y's in my first term, but then I had a y here, so I'll replace that with negative 3. I had a y squared here, I'll replace that with negative 3 squared. I had a y cubed here, I'll replace that with negative 3 cubed. I had a y to the fourth here, I'll replace that with negative 3 to the fourth. And then I'm going to simplify. There is nothing on that line that I have to have a calculator for if I'm in an advanced pre-calculus course. All right, so we're going to go through, and first off, we've got 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? So we'll have 16x to the fourth there, all right? Then here, just like the 2 was raised to the fourth along with this x, same story over here. This 2 is raised to the third, so what's 2 to the third? 8, and then we've got 4 times negative 3 left, right? So negative 12 times 8? Negative 96, yep, negative 96 x cubed. All right, then for the next one, I've got 6 times 2 squared, which is, yes, 2 squared is 4, so 6 times 4 is 24. And then what is negative 3 squared? Yeah, I don't know 24 times 9 off the top of my head, but I could easily run off the side of my paper and scratch that out without a calculator, right? All right, so that's going to give us 216x squared. Then for the next one, negative 3 cubed would give us negative 27, and 4 times 2 is 8. So again, on the side of my paper, I could multiply that, and I'll have negative 216. And then down here, negative 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81, right? And negative to the 4th would be positive or negative? Positive 81. Same exact thing I would have gotten if I had done 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. And if I'm afraid that maybe I dropped a sign somewhere, remember I've got that way to check myself where I can go back and say because this was subtracting, I know my sign is supposed to start positive and it's supposed to flip-flop. So plus, minus, plus, minus, plus. Yeah, my signs are right. Okay. So that's our binomial expansion. Now, sometimes they're not interested in me giving a whole row. We've talked before about something crazy like x plus y to the 21st. They really wouldn't want the whole row for x plus y to the 21st. They would probably want a specific term. So what if you're only looking for one particular term instead of a whole row? Well, that's what we look at in example number 8. For example number 8, they asked me to find the 6th term of a plus 2b to the 8th. Okay, before I can figure out what a plus 2b to the 8th is, I've got to get my pattern. You know how just like up here, before I could find 2x minus 3 to the 4th, I had to figure out what x plus y to the 4th was, right? I had to get a pattern, and then I could put 2x in for x, and I could put negative 3 in for y. I need to do the same thing. I need to figure out my pattern. I need to figure out what's the 6th term of x plus y to the 8th, and then I can go back and put a in for x and 2b in for y. So let's back this up and let's first figure out what would the 6th term of x plus y to the 8th be. Okay, if I'm looking for the 6th term of x plus y to the 8th, this goes right back to number 21 from the homework on the first half of this lesson, all right? So we have worked it out using Pascal's triangle, where you could go through if you wanted to, and you could draw Pascal's triangle all the way out to the 8th row, and then you could count over and you could say, okay, there's the 1st term, 2nd term, 3rd term, 4th term, 5th term, 6th term. There it is right there. The 6th term of x plus y to the 8th would be 56. I could get my coefficient that way. If I don't want to get my coefficient that way, then I could go through and I literally could just give myself some little blanks. And I could say, okay, when I'm dealing with the 8th row, I know that's going to go 8C0, 8C1, 8C2, 8C3, 8C4, 8C5. So I literally could use common sense and count over to the 6th term on the 8th row and get 8C5, and then I could go back to using our formula up here. We did that on number 21, 8C5 was 56. So whether you use the formula NCR to get 56 or you build the triangle down to the 8th row, we've got the 56, right? All right, then we need to figure out what x and y are. So again, I could just look at my blanks. Whether I did this by the triangle or the NCR formula, I could go through and say, okay, I know my x's count down and they start with x to the n. So that would be x to the 8th, x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd. I know my y's count up. So I'm going to have no y, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, y to the 5th. So there it is right there. I could do 8C5, x to the 3rd, y to the 5th, and use my formula for 8C5 to get 56. Or I could use Pascal's triangle to get 56 x to the 3rd, y to the 5th. That is the 6th term on the 8th row for x plus y to the 8th. Now I've got my pattern. Now I can go back and I can say I'm supposed to put a in the place of x and I'm supposed to put 2b in the place of y. So let's do that. Let's put a in the place of x, so a in the place of x, and 2b in the place of y. So if I do that, 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, right? So this is going to give me, 2 to the 5th is going to give me 32 times 56. That's where we're getting this 1792. And then we've got the a to the 3rd, b to the 5th. Now, the way that we just worked that out, we use nothing but common sense based on the information that we had up until today. And you are welcome to do it that way. But if you are more of a formula person, that you're like, oh, please give me a formula and let me stick numbers in it any day, we've been using the first part of the binomial theorem to help us find our coefficient, but there's more to that binomial theorem. And here's what it says. If you're trying to find the r plus 1th term, you can use this formula, NCR, x to the n minus r, y to the r. All right, for our problem, we were trying to find the 6th term of x plus y to the 8th. So you can see that we've got 6 in the place of r plus 1. So if I come down here and I say 6 is equal to r plus 1, subtract 1 from both sides, and r is equal to 5. We already know that n is equal to 8 because the nth row goes with x plus y to the n. We were on the x plus y to the 8th, so we know n is 8. So if we come up here and we put this in that formula, we're going to have 8c 5 x to the 8 minus 5 y to the 5. 8c5 x to the 8 minus 5 y to the 5. That would give me the exact same thing. 8c5 x to the 3rd y to the 5th. So I don't care which way you find that. I personally don't use that formula. I just do it by common sense, the way that we did the first half of this lesson, and kind of building on that. But if you're a formula person and you like that and it seems easier to you, go for it. You are welcome to use that formula. It's going to get you to the exact same place, whatever you like better. Now, if you don't use that formula, there is one thing that I want to point out to you just because of the way they phrased one or two of the homework questions. You'll notice that the exponent on y, by definition, is your r value. So on the homework, there are one or two of the problems that they give you the exponent of y, but they don't tell you the number term that you're on. So they don't say go find the 6th term. They say something like find the coefficient of the x to the 3rd y to the 5th term. Now, obviously, I could come down here and I could count it out, and once I lay out x to the 3rd y to the 5th, I can go, oh, that's the 6th term on that row. But I just wanted to point that out to you. Even if you don't use that formula, that's a big shortcut for you if you can just look at this number and know that's r, because remember that you can add the exponents in any term and know what n is. Because remember, n is the sum of the exponents of any term. So literally I could look at that and I could see r is 5, n is 8, and that would give me a big jump start on that, particularly if I wanted to use that formula. Okay? So here is our homework for tonight on the second half of 9.9, the binomial theorem, and Pascal's triangle.